Hey now, it's Wednesday. You know what that means? We got a book talk on the sched today. Love book talk. You just read a chapter about cells, and we're going to spend so much time with cells as we go here, but kind of an intro to cells through Bryson's book, a short history of nearly everything that we've been enjoying over the last few weeks, right? And then, of course, in class today, you got Bellringer, Ed Puzzle, book talk. Piece of cake.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class. Brains.
Yeah, I've been talking about brains, neurons, nervous system. I introduced you to the neuron yesterday, which is the unit of one neuron is one unit of brain cell, of nerve cell. You put a bundle of neurons together to make a nerve, right? And a neuron has a cell body, these little fingers we call dendrites, and this long stretchy part called an axon. Then at the end of the axon is the terminus of the axon, right? And so nerve signals travel in one direction. One direction, right? And it's caused by what's called an action potential, right? When the action potential is reached, a message, electrical signal gets sent all the way down from one end of the nerve to the other. We played the game yesterday where you were doing action potential. You're waiting for the number to be above 7. When the number was above 7, you squeezed and you went, right? That's the same with nerves. If the number's below 7, they don't go. Action potential. Potential is like the trigger that gets a nerve to go, right? We call it, when nerves at rest, it's resting potential. And then once action potential is reached, nerve signal zips down the length of the axon in one direction from cell body. And then usually at the end here, at the axon terminus, when that electrical signal gets to the end, it signals the end of this nerve, this neuron, to release neurotransmitter. Neurotransmitter are chemicals. They push them out into the intercellular space, and then they may or may not turn on another nerve or turn on a muscle or turn on something, right? That's what they're going to do. Where the neurotransmitter is released, that's called the synapse. The space is called the synapse. So action potential comes down the cell membrane, release neurotransmitter, it gets taken up by the next cell, and it propagates that signal down, right? In order for these guys to be taken up by the next cell, there have to be receptor molecules on the surface of this second cell, right? Imagine, in fact, this is the way a lot of pharmaceutical, like drugs and stuff, work, is they block synapses, or they stimulate synapses when not enough neurotransmitter is made. Like pain relievers. Pain relievers will block synapses between nerves. That way you don't feel pain. I mean, the nerves are still trying to fire, but once they get here, if it's blocked, you can't send a message to your brain, and so the pain is less. Hopefully that makes sense. That's how all those things work. The cellular level. All right, let's get with it then today. You've heard enough of me talking during the bell ringer. Jump right from this bell ringer to the Ed puzzle for today. Finish that bad boy, and then go on to book talk. And then that'll probably take us through the period. I'll probably have a few extra additional items to share with you, but yeah, let's make it a good one. Wednesday.